Well, alright, welcome back. In this part of the lesson on RPG games, we are going to spend some time talking about a collection of scripts that I have already put into your starter project that we're going to be using to make our player move, and in fact make our enemy move eventually when we get there as well. These scripts are kind of complicated. I'll do my best to explain them. Kudos again, a giant call out to Benjamin Anderson from Heartbeast, from whom I used these scripts, with of course him saying that anybody who wants to use them is welcome to use them. So if you look in the starter project that we've got going, you should now have brought in your player sprites for moving up, down, left, and right. If I come into the game, because I got rid of the sprite, the original single image sprite, we don't see anything in there anymore. So before we go in and start playing with the scripts, come in, make sure that you have a sprite associated with the player object that's already been put into the project for you. I'm using SPlayer Rundown as my default sprite. Okay. Now we've got the code, as I said, already in there from these scripts, and once I start moving, you'll see a few things are happening. I want you to look very carefully at how this character is moving. As I move left or right, up or down, when I start moving, the character begins to animate, and when I stop moving, the character stops animating. Right? We're not showing the correct version of each of the images for the player. We'll get that working a little bit later. But we are animating appropriately and stopping as we come to a stop. Now there's something that's built in that's a little subtle and it's a little hard to see. But with these great scripts from the Heartbeast guy, there is in this movement a slight kind of use of fake friction in a couple of ways. One is that our character is not going from 0 in terms of his speed to full speed instantly. Instead, he does a little bit of a speed up. It's very subtle, it's hard to see. Similarly, when the player stops, he doesn't instantly stop. He does a kind of a slow down and then comes to a halt. So let's take a look at these scripts and see if we can start to make sense of what's going on with them. Parts of these scripts are going to look very familiar because parts of them are straight out of what we did when we created our platformer game, and indeed they are a version of what we did way back in the Koala game. So if you open up your player object and you come into the create event, you'll see in here I've already set up a few things. There's a script that we are going to use in order to initialize some variables that we will use for any object in our game that we want to allow to move. In our case, it's going to be our player object and the enemy object. And you're creating your own RPG game. You may have multiple enemies, and all of those enemies can make use of the same collection of movement scripts. All right? One of these movement scripts I've got in the create event for our player, and it's called SpeedUp Movement Object. And if I open that up, all that's happening in this SpeedUp Movement Object is that I'm passing 3 values that will then be assigned to some variables. Right? The way this script is set up, we've not focused really carefully on how to provide information in scripts. We've made use of scripts. We did a bunch of scripts way back in our Evil Clutches game, but I didn't talk a lot about them, so I want to go into a little more detail here. Here inside this SpeedUp Movement Object script, this is my own script, well, it's Benjamin Anderson's script modified for use in our project. But at the very top, you can see we've got a comment here that says essentially what the name of the script is, or close. I can change it here to object. Tells what information it is we should be passing: friction, bounce, and collision object. And then it's got this little section here that says @arg friction, @arg bounce. This is some built-in, it's not code exactly, but it's just like when we do description. We have an @ symbol in description, and then you can put what is occurring inside an action that you are running in association with an event, and then in the event window it will tell what's actually taking place there, just like here, @description player setup shows up here. Well, this @arg followed by some name is used when you go to call this script. If you have listed out any parameters that go with the script in a comment using that @arg, what you get, if you look down at the bottom of the window, is it will then tell you what are the things that you are trying to put in. And then when I click inside these parentheses, it will highlight which thing it is I'm providing a value for. So here I need to provide the value for friction, here for bounce, here for the collision object. So it makes life a little easier when you go to call this script to understand what it is you're supposed to be passing to it. And you do that just by using these little @arg keywords. Yeah, that was a long explanation. So what are these exactly? Well, I demonstrated a minute ago that the way the movement of the player and other objects is going to work in this RPG game is that they're going to have a kind of pseudo friction which will be used to slow them down to a stop. Ultimately, also, they're going to have an acceleration that will cause them to speed up to full speed. They also are going to have a value called bounce. Now, going back to our platformer game. In the platformer game, when we had the player move, if the player was approaching a wall, what we wanted to have happen in the code was we checked to see if the player was going to run into a wall, and if so, we moved them 1 pixel at a time right up until they ran into the wall, and then we had them stop. We had a second kind of movement for our enemies in our platformer game, which was similar in that we would check if the enemy was going to run into a wall. Well, we would move them up to the wall till they hit it, but then we wouldn't stop them. We would instead reverse their direction. So they would move, they would look like they would run into the wall and then turn around the other way and walk off the other direction. What we're doing here for movement in our RPG game is taking those two approaches to movement, the player movement and the enemy movement, and combining them into a single script because they're almost the same functionally, right? One of them causes the player to stop when they hit a wall, the other causes the enemy to turn around the other direction when hitting a wall. This bounce value we will make use of in two ways. One is to determine whether or not we're going to have the object come to the wall and then stop, or come to the wall and reverse direction. And also, we'll make use of this same bounce value to indicate the strength of the bounce when the player runs up against the wall. How sort of firmly do we want them to bounce off in the other direction? All right, that's a long explanation. Finally, the third argument we're passing is the collision object, and this we are using to say which object is it we want to check to see if we're going to run into. In our platformer game, we made use of, in our koala game too actually, we made use of an object for our wall that we placed around out into our room that the player didn't actually see, right? It was there, but it was a single object against which we detected all collisions between the player and that object. And we're going to do the same thing here. You see we've got this O-wall object. We're just using it again. This O-wall object is a leftover from our platformer. So basically we're going to say, in setting this up, that we want our friction to be 0.8. The friction value should be something between 0 and 1. 1 being full-on friction, meaning our player is going to come to an immediate halt. Bounce is 1, meaning what? Meaning yes, we want to bounce. Okay. And then O-wall is the name of the object against which we're going to detect collisions. Whew. Okay, so that's what all of that is. So that sets up those and stores them into values called friction, bounce amount, and collision object. These are instance variables that we will be able to refer to read, or to set and to modify from other objects using addressing like dot syntax addressing. So if we want to say like oPlayer.frict equals something, we'll be able to do that. Okay? There are two other instance variables that we are initializing here inside this setup movement object script. One is our own custom version of speed, and the other is our own custom version of direction called directs, which is maybe not the greatest name. And we're initializing them to 0, but we will update these in other scripts. Okay. Whew. That's a long explanation, but once you get the idea of this setup movement object, you can use it, as I said, for players and for enemies, and they will work basically the same thing, the same way. There are a few other things we're doing here inside the setup for our player. We're setting the image speed equals to 0, and remember the image speed is something you can use to determine if and at what speed you move through the sub-images in a sprite. So our object player right now is using the player run down sprite, which has a collection of sub-images. So we're starting off saying we don't want that to animate, so it's just going to start and sit on the first frame, frame 0. Acceleration is a instance variable that we will use to move up to full speed. Max speed is that full speed. It's basically saying how fast will the player be able to move at full speed. And then this is not anything to do with movement, but we're setting player health equal to 100. All right, that's all set up. Then on our move event, in the step event, I should say, we're going to actually move our player. And this is going to look awfully familiar. Parts of this, at least, should look very familiar because it's a take on what we did in our platformer game. We are checking to see if the player is pressing a left key or right key, an up or a down key. This is different from the platformer. We don't have gravity in this game. So in addition to checking left and right, we need to check if they're pressing up or down. Then we have a local variable called input direction, and we're using a built-in function that we've not used before in order to determine if the player is moving up, basically, or moving down, or moving left, or moving right. And this point direction built-in script, what it does, I've opened up the help here, is it basically, as it says, it returns the direction of a vector formed by the two different components. So we're going to take a point in the room, x and y, and a second point in the room, x2 and y2, and we're going to determine what is the direction from this point to this point out in the room, and then we'll store that information. Here's a little image. So we want to know, for example, if we are on our player and we're looking at the player's x and y, and there's some other object out over here, and that is also at an x and y, we want to know what's the angle, basically, between this object and this object, which in GameMaker, as you know, is going to be the direction, right, from 0 or all the way around to 360 degrees. So in order for us to figure out the input direction, we check between where we're sitting right now, where our player is, and then the second point we're going to look for is the value we get by checking if they're pressing the right key and or the left key, the down key and or the up key, which we've used before, right? And so for example, if they're pressing the right key but not the left key, then the X input will be 1. If they're pressing the left key and not the right key, the X input will be -1. And similarly on the Y, if they're pressing the down key but not the up key, it'll be 1. If they're pressing the up key but not the down key, it'll be -1. So these values are either going to be 0, 1, or -1. 0, 1, or -1. That's what goes here. So effectively what we're going to get is a value that's like, here's 1 point. Sorry, I'm just drawing on the screen. And we're either going to move this direction or this direction, this direction, this direction, this direction, this direction. We're going to move around in a circle, and that will tell us different angles, right, depending on the value of the left, right, up, and down arrow keys. So that is quite useful, right? It tells us which direction it is our player is going to be moving. All right. And then finally, we have an attack input, which we use in our platformer game. Here we're using the X key for attack. Then we come down and we say, okay, if the X input and the Y input are both 0, it means the player is not going to move. So we're going to set the image index to 0, meaning the first image, which is just the player standing there. And we don't want to animate, so we set the image speed to 0. Then what? We're going to call a script, which I've called slow down, which is saying that we're going to have the player stop moving at a certain rate. We're going to sort of apply friction to the player. Now in our platformer game, we basically did the same thing. We checked if these things were 0, then we set the index to 0 and the speed to 0, and then we just set like the H speed and the V speed to be 0. But here we want to not just instantly stop, we want to slow down. So what's happening in the slow down script? It's very short. We are setting SPD, that's our custom version of speed, and we are calling this approach script, which is yet another built-in, or I shouldn't say built-in, another custom script that I've included in the project. What it's going to do is it's going to take whatever the current speed is and 0, basically stopping, and the amount of friction that we are setting, and it's going to use these 3 values to move from our current speed toward 0 at a certain rate. Basically, the higher the number on friction, the faster we move to 0. Okay? So if I look at the approach script, we pass that information in there. What's our current speed? What speed do we want to get to? And what's the rate, essentially, the amount of friction? And we just say we're going to set some local variables saying, okay, if our current speed is less than our target speed, then we're going to return a value that's the minimum of blah, 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 blah. I'm not going to go too much in detail here, but the idea is basically we're going to use these 3 values: current speed, speed we're trying to get to, the rate at which we're going to get to that speed, and then return that information and store it in speed. Okay? And because this is happening in the step event, it gets called over and over and over and over again, meaning basically the player, as long as the player is not moving, they're going to slow down until they hit 0. Okay? All right. If, however, they are pressing one of the input keys, then we want to animate, so we set the image speed to 1. We check to see if they are pressing the left or right. They're trying to move left or right. And if so, then we're going to set the X scale either to 1 or -1. This is left over from our platformer. Then if they are moving, we need to figure out which direction they're moving. So we're going to use this get direction facing script, another custom script that's going to take whichever value we have here in this input direction variable, and it's going to convert that into a value between 0 and 3. Okay? So this is what we have when we have this get direction facing an input direction. This is going to be something between 0 and 360. We're going to take that value and we're going to divide it by 90 and then round it. So if it's 90, then it'll be 0 and we round that. So if it's 220, we divide that by 90 and then we round it down to the nearest whole number or up to the nearest whole number. Okay? And what we end up with is 0, 1, 2, 3, or 4. And then what we do is we say if it's 4, that's basically the same as 1. So we'll set direction facing to 1. So again, our values in this are either going to be 0, 1, 2, or 3. And we're going to use that information, 0, 1, 2, or 3. Ultimately, this is going to be used to allow us to show the correct sprite depending upon which direction the player is going. Okay? We haven't got all that set up yet, but the code is all ready for us once we get the sprites set up so that they will make use of this direction facing the 0, 1, 2, 3 values in order to show the correct version of the sprite. Okay? It's a lot of information, I know. All right, so we're almost done. Then, once we have set up this value so that we can show the correct image depending on the direction we're facing, we're going to speed up. So here we're not moving, and as long as we're not moving, we're going to slow down until we hit 0. But if we are moving, we're going to speed up, and we need to speed up in the correct direction, which we'll use with input direction, at a certain rate up to a maximum value. So it's like the opposite of this slow down. In fact, if we look into this SpeedUp script, it's the same idea. I'm not going to go into all of the details in this script. The value of having these scripts is that you don't necessarily have to understand exactly what's happening, but what we're doing is we are just taking which direction do we want to move, what's the acceleration rate, and what's our maximum speed, and we are performing some calculations, and then we're setting our speed equal to what it needs to be in the right direction, or rather what the speed is, and then we're pointing us in the right direction, and then we're updating the speed again. So ultimately what we're ending up with is just what this says. We're going to speed up our character and get it facing the right direction, but not let it go any faster than the maximum speed. All right. And then finally, after all of these various calculations, we're either saying slow down or speed up or getting all the directions set and all of this, you'll notice that in these scripts, we're not actually updating the X or the Y or the speed or anything else. We're just updating our custom variables. So once all of that is done, we still need to actually move our object, and we're going to move it using yet another custom script. And I'm not going to go into extreme detail here either, except to say that in this script, if you look at this, it should look awfully familiar, because this is essentially the same code we used in our platformer and a version of it in our koala game, where we're checking to see if we're going to run into a wall, and depending on whether bounce has a value or not, we're either going to reach the wall and stop, or here we are, reach the wall and stop, or we're going to reach the wall and then reverse direction. Okay? This is the horizontal version of that. This is the vertical version of that. If we're going to run into a wall object above us or below us, move a pixel at a time until we're right up against it. And then if bounce has some value, then we will reverse direction when we hit the wall by whatever that bounce value is. Otherwise, we'll stop. And then in both cases, we finally update the x and the y, and then we update our custom speed variables as well. So again, if you really want to get into the details of this, I invite you to do it. I just want to talk at a somewhat higher level of what's going on. And then the joy of creating these scripts is that you don't have to ever think about it again. You can just use them. And the ones that you end up using are, you set up the movement, you can speed up or slow down, you can actually move the object, you can figure out which direction the sprite is facing, getting 0, 1, 2, or 3, which we'll make use of here in order to show the correct sprites. And then there are a couple other ones. There's this approach one that I showed you a moment ago that we're not going to get into right now. And then there is this set speed and direction, which does just what it says. You can just directly set our custom direction on our custom speed variable, and we'll use that as we go along as well. All right, that's 30 minutes worth of explaining all of what's going on inside the movement scripts that we are using inside our RPG game. Obviously, there's more and more detail I could go into, but I think this is enough so that you have sort of a broad understanding of what's taking place, so that as you're just using these scripts moving forward, you can just use them, but sort of understand what it is that's actually happening behind the scenes. And that's it for this section. Let's continue on to the next one.